Good morning, welcome to new lecture. Today I will solve two examples using slope deflection method. Let's look at the first, this beam, this continuous beam. This beam is subjected to one concentrated load here, 5 kips, another concentrated load here, 10 kips, another distributed load here, 8 kips per feet. This length is 8 feet, 6 feet, each part is 3 feet, 3 feet. This part is 3 feet. Okay, let's look at two degree of freedom for this system. This system, you can simplify this system. How we can simplify this system? The CD part, it is like one cantilever part. So instead of having that part, I can remove that part and add moment. So I can add moment 5 times 3. So I can do that. So that degree of freedom, the rotation of D is not important for us. But the rotation of A is equal to the 0 because it is fixed support. So degree of freedom here only rotation of B and rotation of C, because this beam will deform something like this. Something like this. Okay, so we have 2 degree of freedom. Let's look at to the fixed end moment. For AB part, it is distributed load, so M fixed AB will be equal to let's see, for this part, this is 3, sorry I made mistake, this should be 3 kips per feet and the length is 8 feet. So M fixed for this part will be 8 squared over 12. That will be equal to 16 kips feet. Because this reaction will be counterclockwise, so positive. M fixed BA will be magnitude, it will be equal but in inverse direction, so negative 60 kips feet. M fixed BC will be PL over 8, so it will be 10, 6 over 8, that will be 7.5 kips feet. M fixed CB, magnitude is the same, this reaction will be clockwise, so it is negative 7.5 kips feet. So these are our fixed end moment for AB span and BC span. Now let's write the slope deflection equation. If I write the slope deflection equations, I can write M AB is equal to 16 M fixed AB, which is 16 plus 2 EI over L, it is 8, times 2 theta A. Theta A is equal to 0. So it is 0 plus theta B. That will be equal to 16 plus 0.25 theta B EI. I can write MBA is equal to M fixed BA, which is minus 16, plus 2 theta B, 2 EI over L, 2 theta B, plus theta A, again theta A, because it is fixed support here is 0, so that will be equal to minus 16 plus 0.5 theta B EI. MBC will be equal to M fixed BC. I find that M fixed BC, it was 7.5 plus 2 EI over L, 6 times 2 theta B plus theta C, that will be equal to 7.5 plus 2 EI over 6. Let's simplify this. 2 EI over 6. I can multiply, I can write 1 plus 3 EI theta B plus 0.66 EI theta C. Let's write MCB. MCB will be minus 7.5, everything will be the same, only you will change theta B and theta C location. So 1.33 EI theta C plus 0.66 EI theta B. These are slope deflection equations. Now let's look at the equilibrium equation. We have one rigid joint here. You see this member is continuous and MBA is this side, MBC this side. The summation of these two should be equal to 0. So I should write at node B or joint B, MBA plus MBC is equal to 0. That is one equation. Another equation I can write, which is clear, MCB plus MCD is equal to 0. Here MCB plus MCD is equal to 0. We know MCD. What is MCD? MCD here 5 times 3. So MCD will be 5 times 3. So we know that MCD is equal to 5 times 3, 15 keeps feet. If I plug this here, MCB will be negative 15 keeps feet. So now I have MCB. Let's plug MBA from here and MBC from here to this equation. If I plug those there, I can find theta And let's see, MBA I can plug from here, MBC I can plug here, MCB I can find MCB I will plug from here, so I can find we will have two equations, two unknown. I can find theta C and theta B. If I plug these equations here and this negative 15 here, I will find theta B and theta C. Theta B, finally, if you plug there, it will be 8.16. Theta C will be 9.7. Now if I put these theta B and theta C in those slope deflection equation, I will find all moments. MAB was 16 plus 0.25 EI theta B. From here, if you plug, I will do for 1, 16 plus 0.25 EI. Of course, this theta you will find in there. This will be 8.16 over EI, this will be 9.7 over EI. So, multiply 8 over 16 EI. That will be equal to 18.04 cubes feet. MBA will be equal to negative 16 plus 0.5 EI theta B. Again, if you plug, you will have negative 16 plus 0.5 EI 8.16 divided by EI. From here, this will be negative 11.91. MBC, it was 7.5 plus, let's see, plus 1.33 EI theta B. If you plug theta B, it will be 8.16 over EI plus 0.66 EI theta C. You will plug 9.7 over EI. That will be equal to 11.91 cubes feet. And finally, MCB will be negative 7.5 plus 0.66 EI theta B, 8.16 over EI plus 1 plus 1.33 EI theta C. Theta C will be 9.7 over EI. That will be equal to, let's see everything is right. AB, it was right. MBA, it was right, I find negative. MBC, this is right. MCB, minus 7.5, that is right, it will be negative 15 cubes feet. So, after I double check my equation. That is right. Okay. After finding this, Then we will look at to each span and we will show these moments. So AB, here I will apply MAB, it is 18.09, this will be 11.9, distributed load 3 kips per feet, this is 8 feet, here you will have VA and here you will have VB left. If you take moment respect to the B, you will have negative VA times 8 plus 18.09 plus 3 times 8 times 4 minus 11.91 is equal to 0. From there I can write VA will be 12.76 kips. If you write summation of force in vertical direction equal to 0, VA plus VB left minus 3 times 8 is equal to 0, you will find VB left is equal to 11.24 kips. So if we look up to the BC span, I can draw free body diagram for that span. BC 10, this is 3, this is 3, this will be 15, this will be 11.91. Here I will have VB right at right side of the support, and here I will have VC. If I take again moment respect to the C, you can find VB right. So VB right will be equal to 4.48 kips. And if you write summation of forces in vertical direction, you can find VC left here. VC left will be equal to 5.51 kips. Now I have all moments and reactions, so I can draw shear diagram and moment diagram for this beam. If I do that, this is shear diagram. As much as reaction, I will move up. So I will go up 12.76 VA. We find that we will move up with constant slope. I will move down. As much as VB left, I will move up. Then as much as VB right, I will move up. So I will reach to the 4.48. Let's see, everything is right, yes. And here this will be 11.24. 4.48. There is no force, I will continue. 10, I will move down. I will continue, so this will be 5.51, positive, negative, positive, negative. Again, after that, we will be at VC, so VC 5.15, I will move up. Of course, If you find another side, you will go again 5 up, come 5 down, and you will close the diagram. This will be positive. This will be moment diagram for entire beam. This is VA. Let's say show everything. This will be VB left. This will be VB right. So this will be VC left. This will be VC right. Okay. Let's look at the moment diagram. Moment diagram here. MAB. MAB was 18.091, if I'm not right. Let's say look at MAB. 18.04. 18.04, if I'm not wrong. So here the moment counterclockwise will create negative moment, negative 18.04. In one location I wrote 18.04, another 0.09. I don't know, one of them should be a little bit off, but I think 18.04. And because it is counterclockwise, it is negative moment. This is distributed load, so moment diagram will be curve shape. Here should be reached to the maximum, and maximum you can find it positive. You will find this 0 point, and you will take moment for left part respect to here. If you do that, if my calculation is right, it should reach to the positive 24. Then MBA, let's see what was MBA. 11.4, if I'm not wrong, or 11.9. 11.9 clockwise, here negative, so it will come to the negative 11.9. After that, here it will reach to the positive 15. There is no force. 1 degree higher or derivative of this will be shear, so diagonal. And here moment 0. If I move from here to here, just before C, 5 times 3, negative 15, negative 15, and then it goes to the positive 15. This will be our moment diagram. Of course, double check these numbers. Maybe I made a little bit mistake, maybe some numbers a little bit off, but this is the procedure because I did this myself. Maybe calculation, whenever I put in calculator I made a small mistake, but it seems right. Okay, let's look at to the next example. Next one, it is again one continuous beam. That's a little bit I draw using scale. This is 6 meters, 9 meters, 30 kilonewton per meter. And here at midspan, I have 100 kilonewton. This continuous beam is subjected to these loads. In addition, at support B, we have settlement. Settlement is downward settlement, and delta B, the magnitude of settlement, it is 30 millimeters. E, Young modulus for this beam, it is 200,000 megapascal. It means 200 gigapascal. I, for this beam, it is 127 times 10 to the power of 6 millimeter to the power of 4. Okay, once we have settlement as support B, I can calculate psi AB. It means angle of A because of settlement. If I attach these 2 points, the dashed line is slope delta over L, the tangent of that angle. It will be delta B over L AB. That will be 3 millimeter divided by 9,000 millimeter. That will be psi AB. From here, psi AB will be equal to negative 0.0033 radian. Why negative? Because this member rotate clockwise. Rotation clockwise, our contract says it is negative, so it will be negative. How about psi BC? Psi BC will be delta B over L BC. That will be 30 divided by 6,000, so psi BC will be 0.005 radian. Why this one is positive? Because if we have settlement here, this member rotates counterclockwise, so it is positive. Let's now, we know all this information. Let's find fixed end moment and then plug in the slope deflection equations. For span AB, fixed end moment for this one, this will be W L squared over 30, this will be W L squared over 20. For BC, we will have both this one will be PL over 8, this one will be PL over 8. And from the direction you can understand which one is positive, negative, positive, negative, positive, negative, counterclockwise positive, clockwise negative, whenever we are putting in the slope deflection equations. But if we draw moment diagram, we should look at to see which one create tension underneath of the beam, we will call that one positive. Which one create a compression underneath of the beam, we will call that one negative. So let's write M fix AB. If I plug in the formula, will be plus 81 kilonewton per meter. M fix BA, it will be negative 125 kilonewton meter. M BC will be positive 75 kilonewton meter. M CB will be negative 75 kilonewton meter. So I wrote formula only instead of W, we will put 30, instead of P, we will put 100. Counterclockwise positive, clockwise negative, I will find these numbers. Then let's write slope deflections equations. M AB will be M fixed AB plus 2EI over L 2 theta A plus theta B minus 3 delta over L, or I can write 3 psi AB. So this will be equal to 81 plus 2EI over 9 2 theta A plus theta B minus 3 times psi AB, it was negative 0.0033. This will be, even I can write here, maybe there is enough space, minus 3 minus 0.0033. This will be MAB. Theta A here is 0 because it is fixed support. So I know this term it is 0. From there I can write MAB is equal to 2EI over 9 theta B plus 0.01 plus 81. In similar way, I can write MBA. MBA, if I plug in the formula and I simplify, I will have 2EI over 9 2 theta B plus theta A, which is 0, minus 3 psi AB minus 0.0033 minus M fixed M fixed BA, which is negative 1, 2, 5, 125, if I'm not wrong. Okay. Double check this number. The M fixed BA, in one location I wrote 125, in another place I wrote 121.5. One of them should be wrong. So of course you can double check. W L squared over 20. W it will be 30. L squared 9 squared over 20. So WL squared over 20 will be M fixed BA. W is 30, L is 9 squared over 20. See, the answer is equal to negative 125 or 121.5. One of them should be wrong, I made a mistake. So you can correct that one. Anyway, let's look at today. From here I can write, if I simplify, 2EI over 9, 2 theta B plus 0.01 minus 121.5 or 125. I don't know which one is right. Final answer should be right. So again theta A is equal to 0, so we will cancel that. Let's look at slope deflection equations for span BC. For span BC, I can write MBC is equal to 2EI over L 2 theta B plus theta C minus 3 psi BC plus M fixed BC. I can plug numbers here, so it will be 2EI over 6 2 theta B plus theta C. Theta C is 0 because it is fixed support, minus 3 times 0.005 radian plus M fixed is 75. For M CB you can write 2EI over 6 2 theta C, again theta C is equal to 0 plus theta B minus 3 times 0.005 radian, this time minus 75. This is M fixed BC. M fixed BC, M fixed CB. This is counterclockwise positive, clockwise negative. After writing all these equations, we can write equilibrium equation. What is equilibrium equation here? At joint B, we know M BA plus M BC should be equal to 0. If I plug that, I will have 2EI over 9 2 theta B plus 0.01 minus 121.5 plus 2EI over 6 2 theta B minus 0.015 plus 75 is equal to 0. From here, if I plug all numbers, we know what is E, we know what is I, what is L. If we plug all numbers in right units, pay attention to the units, don't make any mistake. Theta B you should find is equal to 0.00415 radian. Now, if you plug this theta B in all slope deflection equations, you can find MAB, you can find MBA, you can find MBC, you can find MCB. I will write only the final answer for those. MAB will be 160.9 kilonewton meter. MBA will be minus 18.2 kilonewton meter. MBC will be equal positive 18.2 kilonewton meter. MCB will be negative 166.9 kilonewton meter. So these are our moments. Using free body diagram for each segment, we can find force reaction. So now I can cut these spans and show free body diagram for part AB and part BC. For part AB, free body diagram. This will be 30 kilonewton per meter. This moment will be 18.2 kilonewton meter. This will be 160.9 kilonewton meter. So you can find VA here, you can find VB B, VB left here. Summation of moment respect to B point, you can find VA. Summation of forces in vertical direction, you can find VB left. In similar way, you can show free body diagram for BC. This will be 100, this will be 166.9 kilonewton meter. Here you will have VC, here you will have VB right, and here you will have moment 18.2 kilonewton meter kilonewton. So summation of moments respect to the C, you will find VB right. Summation of forces in vertical direction, you will find VC. So you can find all those. If you find those, this will be 60.8, this will be 74.2, this will be 25.2, this will be 74.8. After finding all these, it is easy to draw shear diagram and moment diagrams. So, shear diagram, as much as reaction at point A or VA, we will move up. So, this will be 60.8. Then, this is linear. The shear diagram will be 1 degree higher, so it will be second order or curve shape. From left to right, the magnitude of load is increasing. It means from left to right, the slope of shear diagram should increase. That means we will have curve something like this, so its slope will increase. This will be positive, this will be negative. If you cut in one point, write summation of forces in vertical direction equal to 0. If you cut and show free body diagram, something like this, 60.8. This is X and this is Vx. If you write summation of force in vertical direction, put Vx is equal to 0. You can find the location here is equal to 0. That will be 6.04 meter from left support. Here again we will move up as much as VB left, that will be 74.2. Then we will continue to move up as much as VB right, that will be 25.2. There is no force, we will continue. 100 we will move down. After that there is no force, we will continue with VC up. We will close diagram, that will be 74.8 positive. This will be shear diagram. Bending moment diagram. In this region should be curve shape and cubic, because this is, for example, x square. It is square shape curve. This will be cubic shape, and at the location this is 0. This should reach to the maximum. Here it will be, if you apply MAB and it is counterclockwise, create compression underneath of the beam. Assume with rand, you are taking point A, rotating in the moment direction, rotating like this, create compression, negative moment, negative 160.9. Then cubic shape will come to the positive side. Something like this. positive one where you have shear forces equal to 0, you can take moment respect to that point. In free body diagram, you will find it will be 83.9 positive. Then here it will be as much as MBA, which is clockwise rotation create compression, negative 18.2. It will come here, cubic shape. Then in this region should be diagonal. Here you will apply the reaction MCB, clockwise create compression, so negative 166.9. If you move from this side, cut just before this, take moment, and because you have here VC as well, if you cut, you will see you will reach to the positive. From negative 166.9 you will reach to the positive 57.5, and then you will attach here negative, negative, positive, positive, positive. This will be moment diagram, this will be shear diagram. Okay, thank you so much for watching this lecture. See you next session. Bye bye.